get ready for this. Get ready for this.
So I think we've got things working. Yeah. So, before I do much of anything, I just want to point out that I've got achievements, or Twitch has achievements. There are achievements that can be obtained on twitch.tv. And yeah, I've got lots of things. I've got a handful of things that are completed, like add 5 channels to your auto host list, or stream for 40 hours in the last month. That was July 2019. So yeah, right now we're pretty close to the Empire business, so stream for 250 hours total. And I've been streaming for 225. And almost a half. But I've been streaming a lot. Probably not as much as some of these more popular Twitch streams, but But the two that I'm more interested in, I think affiliate is what I want. Right? Let's see. Twitch affiliates. And start earning income on Twitch. So that's subscriptions. And bits. Oh, earning game sales. Interesting. So, basically, I need 12 followers, 12 more followers, and 3 people to watch me consistently. I'd be excited if I can get 3 people to watch me consistently. I'd get more excited for 3 people to watch me consistently than I think reaching 50 followers. So, also, I need to open up my Streamlabs dashboard because I've noticed that sometimes my things don't work when it's not open, which kind of sucks. By the way, thank you to WebTD Havakni 1976 for following. Yes, that was 8 days ago. So anyways, how about we continue where we left off the other day? So, that was right here. So, we were making this game, we were following this tutorial for this game to make something like this. And so far, what we've got is our character in the middle of the screen, and it moves. And it doesn't move up or down once you hit the edges. Okay, and that's great and all, but that's still not the final product. So, we go back over to adding some bullet action. And that's the last thing that we were doing. So, let me just do that. Well, we need to implement another listener. So, instead of implementing action listener, and only action listener, we need to implement action listener and analog listener. And then import, and then implement all abstract methods. Okay. And then, like normal, we're just going to move this up. So that way all of our override methods are up at the top. And we'll close this, and this, and that. Let's just close everything. There. So our code is a bit more compact looking. It's not actually too terribly compact, but that's okay, because we're continuing on with the tutorial. So, they say before anything happens, we need to add mapping and listener, like we did last time. So, we'll do this in simple init app, alongside the other input initialization, which is right here. So, input manager dot add mapping, and then mouse pick, new mouse button trigger, mouse input dot button left dot button left, and we don't need that. There. So now we'll just import that and save. So that adds mouse pick to our left mouse button, just like we added down to the down arrow key. So now we need to do, I'm actually gonna move this up. Okay, and then, oop, don't want that. Input manager.add listener, this mouse pick, and there. And whenever we click the mouse, the method onAnalog, so this one here, gets called. Before we get to the actual shooting, we need to implement a helper. Oh. That doesn't work. English. We need to implement a helper method that'll give us the direction to shoot at by subtracting the position of the player from that of the mouse. Interesting. A little bit of math. Fun math, kind of. But before we do that, I just want to do a little bit of extra stuff. Because I'm not a huge fan of using the arrow keys, because that's where my mouse goes. Or that's with my mouse hand. So I'm gonna do key W, key, oh wait, no. Left is A, D is right, up is W, and down is S. And now, that crashed because it threw a new that. So we'll just clear that out and run it again. So W A or D S A. Also the arrow keys still work, which means this is how you can change some of your button maps and stuff, which is actually pretty nice because you can have multiple keybinds for something. So like melee would be mouse 4 or something, but I don't actually know if that would work with this. I don't know. It'd be interesting though if it did. Anyways, now we need to go to onAnalog, which will type in, or actually no, not onAnalog. We need to write the helper method, which is private vector 3f get aim direction, and then vector vector 2f mouse equals input manager dot get cursor position, so we're getting where the mouse is on the screen, and then vector 3f player position equals player dot get local translation. Okay, so there's that. And we need to import vector 2f. Okay, and then vector 3f diff. I want 2 f's instead of 1 f because difference has 2 f's. Equals new vector 3f mouse dot x minus player pos dot x mouse dot y minus player pos dot y 0. Okay, and then return diff dot normalize local. And that should work, right? Yeah, it's just not used yet. Okay, so now we go to on analog, and we need to make sure that the user is, or that the player is alive. So, if, and then we need to cast it to a boolean, so it's true or false. Player dot get user data alive, which is the user data that we put to see whether or not the player is alive, which is why it's called alive. And then if name dot equals mouse pick, so basically if the if the left click button has been pressed, then we'll do the code. And then if system dot current time in milliseconds minus bullet cooldown is greater than 83F. Okay, so basically if our bullet is faster, or no, if the time between when we last shot and when we're trying to shoot is more than 83F, then I guess it'll let us shoot. And then bullet cooldown equals system dot current time in milliseconds. So I feel like I'm missing something, but it's probably a variable up at the top that we need to add. So I'm just gonna push on through. Vector 3f aim equals get aim direction, and then vector 3f offset equals new vector 3f aim dot y over 3 negative aim dot x over 3 0. Okay, so we're moving it to the side a bit, and then initialize bullet 1, and then spatial bullet equals get spatial bullet, and then vector 3f final offset equals aim dot add offset dot mult 30. So basically we're creating a final offset vector that is our aim plus our offset, and then we're multiplying it by 30. And then vector 3f trans equals player dot get local translation dot add final offset. Okay, and then bullet dot set local translation trans. Okay, and then bullet dot add control new bullet control aim settings dot get width get height And that's it. And then semicolon. And then bullet node dot attach child bullet. Yes, I feel like I'm missing stuff. But anyways, following on through again. Initialize bullet 2. And we're just gonna not delete all of that. Instead, we're gonna copy and paste. And then bullet 2. And then final offset is aim dot add offset dot negate dot mult 30, and then transformation or translation, I guess, is get local translation dot add final offset, and then bullet 2 dot select set local translation and add control, and then attach child bullet 2. And that's it. Yes. Bullet cooldown is a long variable we initialize at the beginning of the class. So, that means private long bullet cooldown equals 0. And actually, we want that to be system.get current time in milliseconds, right? System dot current time. There. So that's the bullet cooldown. Okay. So now there's bullet control and bullet node. So we have this because we're spawning twin bullets next to each other. Okay. Initialization in simple init app is pretty much just the bullet node, and that's bullet node equals new node bullets. Then GUI node dot attach child bullet node. Okay. And then private node bullet node, just like that. If you go ahead and start the game, you'll be able to see the bullets appearing, but they're not moving. What's the problem? Bullet control. Yes. Of course it's not gonna work because we don't have bullet control. So, we need to add bullet control. So we'll do new Java class and do bullet control. Okay, so bullet control extends abstract control, and we'll import and then implement the methods. Okay, and then private int screen width, screen height, and then private float speed equals 1100f. So that's going to be the speed of the bullets. Public vector 3f direction. Then private float rotation. And then public bullet control vector 3f direction. Int screen width, int screen height. And then this dot direction equals direction. This dot screen width equals screen width. And this dot screen height equals screen height. And then we're just gonna fix this spelling mistake there, and then import vector 3f. So now we can go to control update. And then we're going to do add our comments and do spatial.move direction.mult speed times TPF. Okay, and then rotation is float actual rotation equals monkey blaster main dot get angle from vector and direction. Okay, and then if actual rotation is not equal to rotation, then spatial dot rotate 0 0 actual rotation minus rotation, and then rotation is equal to actual rotation. Okay, so we're making sure to see if it's rotated or not. And get angle from vector. That's going to be another class we need to make, right? Yes. It says you may have caught this method call. Refers to a short static mathematical helper method in the main class. And he created two of them, one for converting an angle into vector in 2D space, and the other converting such vectors back in an angle value. Okay, so we'll get to that one later, I guess. And then check boundaries vector 3f location equals spatial dot get local translation if location dot x is greater than screen width, or location dot x is less than 0, or location dot y is greater than screen height, or location dot y is less than 0. So basically, if the bullets are on our screen, or if they're not on our screen, sorry, then spatial dot remove from parent. Okay, and then this one just goes away. And it is location instead of LOC. So we'll just fix that. Okay. And then my Fitbit yells at me to take more steps. I say no. Anyways, now we have to go back to Monkey Blaster main and go here and do public static float get angle from vector 3f vec, and that's vector 2f vec2 equals new vector 2f vec dot x vec dot y. Since it's only a two-dimensional vector instead of a three-dimensional, it only needs x and y, not z. And then return vec2 dot get angle. Okay, and then we'll implement his other helper method, static vector 3f get vector from angle float angle return new vector 3f fast math dot cosine of angle fast math dot sine of angle 0. And that's a triangle thing. I know that's a triangle thing because I had to deal with it in college algebra. Of course, I don't remember a damn thing that I did with them. And I don't remember why this, or how this works. But, actually, I think I do. So, basically, if we have our OneNote open, come on. No. Add notebook and random stuff. Okay, so basically, if we've got our, so we're getting an angle from a vector, and actually we're also getting a vector, so we're getting an angle from a vector, and a vector from an angle. And what we're doing here is, let's say we're getting a vector, okay? And I'm just going to write it as ints instead of floats, because floats make things more complicated. Ints are just whole numbers. So I'll just do like draw u 3 by 4 and then 0 because we're ignoring it. Okay, it's actually going to be a vector 2f, so we're going to get rid of the 0. So it's just a 3 by 4. And that's our vector. And then there's some math in get angle. A tan 2. So what is a tan 2? Math.atan2. And it's compiled code. Of course it's... Okay. Well. How about... I assume... like a tan 2 takes the tangent of 3 and 4. Yeah. So I guess that's what it does. But let's say we've got a 90-degree angle. Let's just call it... Actually, let's do 45. So 40. Okay. Can I just do this? I'm just gonna try typing. So we've got our 45 degrees. Okay. And we're taking the cosine, or so x equals cosine of 45, and then y equals cosine of, or not cosine, sine of 45. And if we look at it, sine or cosine is the adjacent, so cos equals adjacent over hypotenuse, right? Yeah. So what the cosine function does, I guess, is we give it 45, and it tells us what x and y are. And if we look, cosine of 45 is 0.52. Oh, wait. Degrees. And cosine of 45, 0.7. Okay. So 45 equals 0.7. Stop putting 45 after it. So 45 equals 0.7. Okay. And then we're going to look at the sine, which is the opposite over the hypotenuse. So if we're looking at it like a triangle, let's see if I can draw again. Okay. Triangle, this is the hypotenuse. We'll just say this is the adjacent one, and this is opposite, right? So we're looking at this right here, or this angle, and that's going to be 45. Okay, so basically what sine looks at is this divided by that. And I think that gives us our x, so that'll be this right here. And then sine is opposite. Oh wait, no. So this is sine. Sine gives us our y. Wait. Okay, I'm confused by this, but basically we're getting two things. Okay, this line here. Let's see. Yeah, this line here and this line here, and we're basically getting the point where, like, over here or something, and then that's going to be our we're basically getting these two lines from this angle right here. And that was a very shitty math confusion thing. So anyways, we're just gonna go back. Okay, so now we'll run our code. And now we're shooting wherever we point. So we can move around and and the angle of our bullets changes as we move around our mouse. And I'm just holding down left click. And I think that's the end of that tutorial. So, it's kind of nice though that it's kind of smooth and fast, or seems kind of smooth and fast. So anyways, I'm gonna hit that, and we're gonna try to find this guy's next post, I guess. Which I guess is enemies and sounds. So, in the first part, we implemented the ship and let it move and shoot, which is what we're doing now. And now we're adding enemies and sound effects. So, I guess I want to do... Do I want to do enemies or work on the sounds? Playing sounds and music. So we need to create a class called sound. And then set up our asset manager, load the sounds. And yeah. So let's take a look at the sounds they've provided for us. And I guess see what we're getting into next time. Okay. Assets. This is going to be sounds. There are 8 spawn noises and 4 shoot noises. Pause our music here. So that's 1. This is 2. So it sounds a little higher pitched. That's higher pitched. Okay, so they're just getting higher in pitch. So if I look at the code, see if I can. Let's see. For I is 0, I is less than shots dot length. Okay, we create new audio mode. Sound shots dash 0 plus, and then whatever. Okay, so shots dash 0, 1 through 4. Yes. And so basically it's gonna go through all 4 of these sound effects. So if I open with where is it? Access to, send to, share, play. Nope. VLC. Let's just open VLC by hand. And it's shuffled. Why is it shuffled? Okay, we'll put it in order.
What's
And
that?
I'm streaming, dude.
You want me to
Okay.
wash your car? Give
No.
a rent. I'm renting Dad's and mine. Get it while we're doing it. Anyway.
Thank you, though.
Yep.
So I'm gonna play these in order. And it's gonna be a hell of a lot faster. So if I were to look at our tutorial again. That's the whole series. So by the end of this part, so you can kind of hear it, the shooting just kind of go up in pitch and change as you hold it. Yeah. So then we've got 8 different kinds of explosion. So I think these are either for the different enemy types or making things a bit more interesting like they did with the shooting. And if we look at explosions, it's just gonna play the oh wait. So it actually shoots, so it plays a random shot sound, and it plays a random explosion sound too, which makes it more interesting. Same with the spawns, which is why there are lots of them. And then we've got music.ogg, which is a 2.5 minute long piece. And it just kind of plays while we're it just kind of plays while we're playing the game, I assume. And then okay, so that was pretty cool, just with the music. Let's see. So it's setting itself up to loop. I think that's pretty cool. And it actually sounds kind of nice. So, let's see. Shots, explosion, sounds. Audio node music. Let's see. Load sounds. Music creates new audio node with the music thing and sets it to loop. So also to play sounds, we can just call, dot play, or if we want it to do like multiples or like multiple at the same time, we call play instance. That's cool. And then it's just kind of telling us, hey, here's some of the big parts you need, and then I'll let you do all the hard work of adding in where they go. And all the codes for the sounds at the appropriate places in the main code. And this one tells you how to add a post-processing filter, and they're going to have a GUI and black holes. Okay, we'll go forward a tutorial just to kind of see what we're doing. And we're adding another 2 classes, and that'll be like a heads up display, and I assume another unkillable enemy, right? maybe. Also, it takes three. It takes 3 parts to get the base gameplay done, and then I guess 1 for the graphical effects. So probably, I think if we were making a game on our own without the tutorial, it might be a better idea to just simply get the gameplay down first before we even add like music and sounds and stuff. But we're just going to be adding particle effects. Interesting. We're making it so that way our player emits fire. Wow. So this is going to be a pretty interesting game. And also, this makes me think of this kind of makes me think of like a bullet hell type game. Yeah, so like that gives me an idea. We could expand on this tutorial and change some things and make it like a bullet hell game instead of just, well, okay. What genre is Geometry Wars? Because that's what they said it was based off of. Multi-directional shooter. Okay, multi-directional shooter versus bullet hell. So, shoot 'em up is a subgenre within the shooter subgenre of the action genre. Let's see. So, a new type of shoot 'em up emerged, variously termed bullet hell, manic shooters, and maniac shooters. And they require the player to dodge overwhelming numbers of enemy projectiles and called for more consistent reactions from players. They arose from the need for 2D shoot 'em up developers to compete with the emerging popularity of 3D games. Huge numbers of missiles on screen were intended to impress players. And yeah. That's interesting. So, also, this tutorial gives us all the information we need to make 2D games, though I'm sure it can be adapted to make 3D games. But it's going to be difficult. But 2D games are a good place to start. Because, come on, 2D games are easy. You don't have to account for one direction. And also a lot of cool games and fun games that I've played have actually been 2D. Games like Terraria, Geometry Dash, a lot of the bullet hell games that I've seen, you name it. But that's going to be for another stream. Actually, tomorrow, I'm going to try streaming tomorrow. So tomorrow we're going to be working through enemies and sounds, and depending on how long that takes to complete, maybe we'll work on the HUD and black holes. But I can't wait to get to the particles, because I like particles. So, yeah. But I'm starting to have fun with this tutorial series. And it'll be even cooler once we get to finish it and adapt it to what we're doing. So we'll just put it this full screen. Also, the playing field of this is a lot bigger. Yeah, the playing field in 1080p is a lot bigger than the playing field in 640 by 480. And I'm not sure if I like that, because that means that it might get easier or harder depending on the size of your screen. But I guess that's okay for now. That's a problem we're gonna have to come across when we get to expanding our game. But for now, I'm just gonna clean up our spacing a little bit. And yeah. I don't like how it says these can be final. I mean, I'm sure they could be final, but I don't want them final. But we'll also go through and clean up our code and see if we can make it nicer and better once we're done with this tutorial. So that's probably going to be 2 or 3 streams. 2 or 3 days. But I look forward to seeing what we can do with it afterwards. So anyways, thank you all for joining me today, and thank you all for watching the VOD on YouTube, if that's what you're doing. And I hope that you enjoyed and learned something. Yeah. And I hope you decide to join me when I'm live, or join me again, tomorrow. Planning on streaming tomorrow. So, we'll count on tomorrow. Anyways, thank you. Bye.